Greetings to all the viewers. Now the session is going to continue with water and its treatment concepts. This is the part of engineering chemistry. We are dealing with water and its treatment, unit 1 of engineering chemistry. Boiler troubles is the topic taken for the day. Here, if you are taking water in a boiler, so boiler is used to give the steam. The steam can be used for various purposes in the industrial application. Steam can be used as a fuel in order to go for further kind of heating process and etc. That steam also used for the manufacturing of power, electricity generation is also possible. Apart from that, steam used to increase the pressure, and that pressure conditions used in the industry for various driving instrumental that can be used to drive that instruments in the industrial process. That's the reason why steam is the steam, that means water is considered as engineering material, where a boiler is the big instrument, cylindrical instrument. It will be it can be continuously heated in order to generate the steam. Hot water vapor is said to be steam, right? So here the topic is about boiler troubles. Whenever you are boiling water in a boiler continuously in order to generate the steam, which is the engineering material and most pivotal applications in the industrial purpose. During the process, can you observe any kind of troubles in this boiler? Though that is the topic taken for the day, right? So let me discuss regarding boiler troubles. A boiler is the closed vessel in which water under pressure is transformed into steam by the application of heat. You are heating continuously so that water will be boiled. Boiled water used to generate the high energy containing water vapor. That water vapor with the high energy, high heat content is said to be steam. The steam so generated is used in industries and even in the hydroelectric power generation. So power generation is also possible. In the modern pressure boilers and the laboratories, water required is used pure than distilled water. In order to boil the water in this boiler, in order to generate the steam, so it must be free from all kind of contaminants, and distilled water might be taken in order to avoid any kind of problems during the steam generation. Boiler fed water should correspond with the following composition. So here the optimum level, optimum conditions in order to make a smooth manufacturing of steam by this boiler boiling process. Its caustic alkalinity should be in between 0.15 ppm to 0.45 ppm, right? Alkalinity may causes caustic embrittlement, that is the kind of corrosion. So here alkalinity means for the basic nature. If water is having slightly hydroxide ions in the water, that generate the kind of weakening of the boiler and the corrosion, decay of the boiler, and the steam generation may not be possible. So here the ambient alkalinity of that water sample must be 0.5 to 0.45 ppm. It should be free from dissolved gases like oxygen, carbon dioxide, in order to prevent boiler corrosion, right? So whenever oxygen is there, that used to induce the rusting process. Even carbon dioxide acid is the accelerator of the corrosion process. That's the reason why. So whatever boiler fed water you're boiling, so that must be free from oxygen and carbon dioxide gases. Then only we can minimize this corrosion process, right? The hardness should be in the range of 0.2 ppm. That is extremely negligible. By ion exchange process, 0.2 ppm less than this hardness containing water we can generate. So that's the reason why proper water treatment is required before feeding water into this boiler, right? So then only we can avoid kind of harmful impacts during the generation of steam, and the troubles can be mitigated. Excess of impurities in the boiler fed water generally cause the following problems. If impurities present, they are used to generate the sludges, scale formations also possible, caustic embrittlement may be possible, priming and foaming possible, and boiler corrosion is the consequence because of the impurities present in the boiler fed water. These are called boiler troubles. scales and sludges, caustic embrittlement, priming and foaming, boiler corrosion, all said to be what? They are called boiler troubles. So among all, we will discuss scales and sludges formation and what kind of adverse impact induced with this, also discussed in the session, and we will continue remaining topics in the next session, right? So here, scales and the sludges. Boilers are employed for the steam generation in the power plants where the water continuously heated to produce the steam. As more water is removed from the water in the form of steam, the boiler water get concentrated where the dissolved salt progressively reaches the saturation point. For example, boiler is the big tank. You are boiling the water continuously. Whenever boiling taking place, what happens? Liquid water got vaporized and steam generated continuously. You are collecting that steam. Whenever that tank, for example, its capacity is 100 liters, 100 liters of water you are continuously boiling, what happens? So after few hours, water is evaporated and steam is collected continuously, so that the water level within the boiler got lowered. 100 liters of the water initially, now for example it reduced to 10 liters only. Now what happens during that evaporation process, during that vaporization process, all the contaminants whichever present in the water may not be vaporized, rather they settle at the bottom. Hence water got concentrated. Whichever water left in that boiler will be concentrated one, and that may reaches the saturation point, being excessive impurity content within the water. 100 liter water contaminates is equal to 10 liter water contaminates. That means what? So 100 liter waters, whatever contaminants present, that spread over the entire bulk water. Whenever water continuously removed, water quantity reduced, but the impurity content not. That means what? So impurities are in the high concentration now because water level decreased, right? So that is said to be saturation point. At this point, dissolved salts are precipitated out and slowly settles at the inner walls of the boiler plate. The precipitation taken in two ways. Whenever concentrated water still subjected to boiling process, there are two possibilities. One is precipitation taken at the bottom, or else on the walls of that boiler, deposition of these impurities may take in place, right? So here is the definition about the sludges. Sludge is the soft, loose and slimy precipitate formed within the boiler. It is formed at the comparatively colder portions of the boiler and collects area where flow rate is low, right? So sludge is nothing but very soft and loose slimy material. It is the precipitated one only, but it is having a kind of easy removable tendency, being it is softly made. So the sludges are easily removable. So especially they can be deposited at the cool areas of the inner portion of that boiler parts. So wherever cool region is located, at the curvatures, at the bendings, at the bottom region, so wherever cool portions are present, there the sedimentation of these soft, loose, slimy precipitates called sludges will be deposited. So magnesium carbonate is the example for the sludge formation. Magnesium chloride, calcium chloride and magnesium sulfate. So most of the magnesium salts are generating sludges. This is very simple to remember. Magnesium carbonate, chloride and sulfate, calcium chloride are the causes of sludge formation. Easily removable material, but that is also the kind of very dangerous problem if it is not monitored and removed from that boiler. So that boiler pressure got increased because it will block the circulation of the steam, right? That's the reason why we need to observe, we need to remove the sludges time to time, then only it is possible to generate the steam continuously, right? So if you observe this boiler, for example, this is the surface of the boiler where the sedimented particles you can notice over there, they looks like a loosely bonded material only, but they, whenever they are present in the water, they are creating difficulty while transformation, while movement of the steam. That's the reason why sludges are not preferable within the boiler during the steam generation. Reasons for the formation of sludges. Dissolved salts whose solubility is more at hot water, less in cold water produces sludges. So sludges are generated due to the contaminants of magnesium and calcium chloride. So whenever they are present, they are forming such kind of loosely bonded material called sludge. What happens if sludge generated within the boiler body? Sludges are bad conductors of heat and results in the wastage of heat and fuel. Okay, whenever water got contaminated, water got concentrated because of the sludge formation that forms a layer at the bottom. Whenever sludge layer is generated, that is a bad conductor that becomes insulator of the heat. Whenever you're boiling continuously, still that heat not reaching the water and steam generation may not be possible continuously. So that we need to provide the higher extent of the fuel to that boiler, then only steam generation is possible. So here the wastage of heat and fuel is possible. Being it is a bad conductor, it will restrict the heat flow from the outer region to inner region. Excessive sludge formation leads to the settling of sludge in the slow circulation parts. Whenever that circulation is becoming difficult, then what happens, that used to increase the pressure of the steam circulation. If not possible, steam will be blocked within the boiler only, so that increase the pressure, so that blasting of boiler may possible because of these sludges at the cool portions. Prevention of the sludges. Now, if you know the problem, what they are causing, so then the term we need to prevent that kind of cause adverse impact to be mitigated by using soft water which is free from the salts like magnesium carbonate, magnesium chloride, calcium chloride, and magnesium sulfate. These are the causes of sludge formation, right? So that we need to take care to remove these kind of salts before feeding into the boiler. Water must be free from such a kind of dissolved salts. Then there is no provision for the generation of a sludge, because they only the main cause for the sludge formation. So that we need to take care to remove them before feeding into the boiler. So the sludge formation completely mitigated, right? By blowdown operation. Blowdown operation means if you are taking 100 liters of water within the boiler for the generation of steam, if you are heating continuously, after 10 hours, for example, the water content is extremely less. For example, 5 liters of water left in, but it is of totally precipitated form and contaminants present in that. Simply you can discard that water and fill it with the fresh water. That is called what? Blowdown operation. Blowdown is nothing but replacing concentrated water with the fresh water is called blowdown operation, right? So frequently we need to do this kind of process in order to avoid the contaminant concentration, right? So that sludge formation will be prevented. Next topic is regarding the scales. Right, scale is also the part of boiler trouble only. Scales are hardly adhering precipitates formed in the inner walls of the boiler. Scales are stick very firmly on the inner walls of the boiler body. It's removed with the chisel or the hammer. Scales are formed by decomposition of calcium bicarbonate in the lower pressure boilers. If you are considering this is the boiler inner part, and where you can notice the sludges. Sludges are loosely bonded, that may not create any problem. But scale, if you are observing the scale that is firmly bonded on the surface, it used to form a layer, very thick layer on the surface of the boiler, and even by scratching it is impossible to remove, very difficult to remove. Those are called as scales. Being they are hard and highly strongly adhering materials, that's the reason why scales are very difficult to remove, right? So this is the way a layer generated within the surface of the boiler because of the continuous boiling of this water, that is called a scale, right? Reason for the formation of scales. Scale formation may taken by different processes. Decomposition of calcium bicarbonate. Calcium bicarbonate at higher temperature decomposes to calcium carbonate, which is insoluble salt, forms a scale in low pressure boilers. Calcium bicarbonate if present in the water, so that is the temporary hardness of the water if present, while boiling process immediately bicarbonate decomposed into calcium carbonate, water and carbon dioxide will be formed. Calcium carbonate, if generated within the water, that is insoluble, water insoluble compound, and able to generate a white layer on the surface of the boiler, being it is insoluble, right? This is the way a film will be generated whenever calcium bicarbonate present in the water. And another magnesium chloride. Magnesium chloride is also whenever heated to higher temperature within the water, magnesium hydroxide will be originated. Magnesium hydroxide in addition to hydrochloric acid. The generated magnesium hydroxide is water insoluble once again, and this is also a reason for the scale formation. This is also the scale. Magnesium hydroxide is also the scale. Right, so this is the way a scale formation is possible. Decomposition of calcium sulfate. Calcium sulfate is also another cause for scale formation. There is a peculiarity for this calcium sulfate. The calcium sulfate solubility decreases by increasing the temperature. At normal temperature, calcium sulfate is a water soluble substance. As we are rising temperature, calcium sulfate will be precipitated, being solubility decreased at the higher temperature. So it able to generate a film over the boiler, and it is the kind of a scale formation. Especially we can notice such a kind of adverse effect in the high pressure boilers. High pressure, low pressure is nothing but based on the extent of steam generation. Steam is the main output of these boilers. Whenever you are generating the larger extent of the steam, whose quantity is measured in the pressure, right? That's the reason why high pressure boiler is nothing but that able to generate the excessive quantity of the steam, and a low pressure boiler is nothing but less quantity of the steam generating boilers. Based on its capacity of steam generation, we can categorize low pressure boiler nothing but less steam generation, high pressure boiler nothing but high amount of steam generation, right? So here, whenever high pressure boilers we are using in the industrial scale, bulk scale synthesis of the steam, at that condition, calcium sulfate scales are most common, being we are rising temperature to higher for the water, so that calcium sulfate got precipitated and forms a film which is very strong, and it is the example of the scale formation. And even silica. Silica is nothing but sand. So there is an obvious condition, water may accompanied by the sand whenever you are taking from the river water or oceanic water anywhere. So at that condition, silica, though it is present in very minute quantity, small quantity, it able to generate the calcium silicate. If calcium impurity is present in the water, calcium hardness present in the water, and silica if mixed with, there is a formation of calcium silicate. And another provision, magnesium may binds with silica, there is a formation of magnesium silicate. It's a very hard scale, very difficult to remove if such a kind of scales are originated within the boiler. If sand is present within the water, very difficult to remove them. So this is the way silica is also one of the cause for scale formation. Now, what happens if the scales are formed within the boiler? They are a kind of simple layers generated on the surface of boiler. What they will, what kind of impact they will show, right? Wastage of heat and fuel is possible, being again scales are also the poor thermal conductors, so that heat may not be transported from the outer heating source to the inner boiling water. That's the reason why. So that's the reason why heat will be wasted and fuel consumption will be larger. So for example, if you are continuously providing the heat, if it is normally transported to the water, immediately water got boiled and steam generated. That is a natural process. There is a scale in between. For example, so boiler surface is occupied by the scale that is blocking the heat transportation. If heat is not supplied to the water, water may not boil sufficiently. If water boiling is not sufficient, so the steam generation may not reach its limit. That's the reason why here the requirement, in order to reach the requisite quantity of the steam generation, we need to heat to higher temperature, and a large amount of fuel consumption is required, so that it will be wasted. and lowering of boiler safety. Whenever you are rising the temperature than its ambient level, continuously boiling the water, so that boiler safety got reduced, its durability got lowered, it is becoming soft, weaker, and it may distorted because of the higher temperature and the longer time for the steam generation, right? Decrease the efficiency. So the boiler productivity got lowered. How extent steam generation is calculated? Actually, that extent boiler may not be generating because that surface is totally occupied by the scale, which is a kind of obstacle used to avoid the boiling process, and steam generation will be lowered, so that obviously efficiency of the boiler will be reduced. Danger of explosion being as scales are blocking the transportation of these steam vapors within the system, within the boiler, so that steam whichever generated will be accumulated within the boiler only, and pressure will be sudden rise in the pressure may take in place. That is also the cause for the explosion of the boiler. Blasting may take in place. This is the way a kind of dangerous impact will be induced by these scale formations. Now you know what are the causes, how the scales will be generated, and what kind of problems we will face if the scales are generated within the boiler. Now it's turn to how to remove these scales from the water. How can we remove them? Prevention of the scales. If the scale formation is soft, then we can remove simply by scraping process, and by using wire brush, by scratching, you can simply remove them. If the scales are some extent soft, by giving thermal shocks and sudden heating and lowering temperature, so that scales will become brittle and easily removed by simple brush. Okay, so whatever boiler is there, so what we have to do, empty boiler should be taken, and you need to continuously heat that boiler to higher temperature. Whenever heating taken to extreme level, suddenly you need to cool that one immediately. Entire boiler body should be cooled to the lower temperature by quenching, so that the scale whichever present on the surface will become brittle and immediately detached from the surface. This is the way thermal shocks used to remove that kind of scales generated within the boiler. And if scale is very hard, it's very formed, if a hard scales are generated by this calcium carbonate. So calcium carbonate being, it is a basic one, very simple treatment. This is called chemical treatment. So here simply 5 to 10% the hydrochloric acid can be used within, so that immediately you can discard this calcium carbonate, being it is reacted with hydrochloric acid and neutralized, and the surface film will be totally detached. This is the way chemical treatment can be applied, and specifically calcium carbonate scales will be discarded by this method. If calcium sulfate or magnesium, any kind of magnesium salts also present, it's very simple to use EDTA treatment. EDTA is ethylene diamine tetraacetic acid. It is a hexadentate ligand which having stronger affinity to form a complex with calcium and magnesium salts, so that it able to react with the EDTA, react with calcium and magnesium, and that able to dissolve in this EDTA solution by the complexation. Hence, you can remove the scales. These two processes, calcium carbonate scale and calcium sulfate scale removal, is the part of chemical treatment, right? So by this scale sludge causes of formation, what are the definitions, and what problems we will face, and finally how to remove them. All the topics completed. Now it is time to compare sludges and scales. Sludges are defined as they are loosely bounded and they are non-adherent precipitates and very slim in nature. In case of scales, they are very hard in nature and the thickness will be there, and strongly adherent precipitates on the boiler surface. Sludges are mainly generated due to magnesium sulfate and magnesium chloride. Magnesium salts are inducing sludges loosely bounded. In case of scales, calcium sulfate, calcium bicarbonate are the causes for the scale formation. Poor conductance is given for the sludges. That's the reason why pipelines totally blocked because of sludge formation. Again, here in the scale formation, there is the same kind of symptom. Poor conductance will be induced, and they're also causing a kind of higher extent of fuel consumption, and improper boiling of water may taken, and explosion of boiler is also possibility some extent very difficult process. Sludges can be prevented by periodical replacement of concentrated hard water with the fresh water. This is called a blowdown operation. Scales can be removed by special methods. We have to apply like external treatment of water, ion exchange process. Water will be free from all kind of impurities within before feeding into the boiler. That is called external treatment. Internal treatment, after feeding into the boiler, you may go for the colgan conditioning, phosphate conditioning, carbonate conditioning. Mechanical scrubbing may take in place. Thermal shocks you can apply, and the chemical treatment in order to remove the scale formations. This is the way entire process of boiler troubles related with the scales and the sludges completed. Hopefully you understood the concept very well, and you can subscribe the channel, watch regularly, and watch till the end of the concept what we discussed now, so that you will get the sound knowledge about the content. And subscribe the channel, we will get the new content every day. Share with your friends so that we will get more interest to go for such kind of uh, new concepts every day. Thank you very much. Signing off, Dr. Kavitha Kottireddy Kota.